Okay, we're back again. So now what do we want to do? We want to, yes, so we're in our thesis folder, PWD, we're in thesis, and we want to make a new file called draft.txt. So we're doing that here using the nano command, which if you run it, is actually going to open up something that looks totally different in your terminal. And this is basically a little text editor. It's a very lightweight text editor. It can run just straight from the terminal window. So now I'm going to add something to my draft. I'm going to say this is my introduction. And you should see if you've used the nano command down the bottom of your terminal, you've got all of these little instructions for how to navigate nano. So these are all the commands you can use to save the text, to move around, to read the file. So what I want to do now is I want to save this file. So we should have somewhere down here. Okay, so we're going to use the write out. So that little caret symbol means control. And for those of you on a Mac, it is still the control button. It's not the command button. So I'm going to go Control O. And then we've got file name to write. And I'm going to press press enter. Sorry, not tab. I'm going to press enter. So now this is my introduction has been saved to draft.txt. But we are still in the text editor because Nano wants really explicit instructions and it needs to be told that we're ready to leave. So then we're going to use the exit command that we've got down here. So again, we're going to do Command X, and that should bring you out of Nano and back into the terminal exactly the way it looked before.
Do we have to save it or something?
So that's what the Control O does. Control O should save it for you. If you didn't already do Control O, so if I go back into Nano draft.txt and I add something else to it, and I didn't do Control O, I'm pretty sure if I do Control X, it will say to me, do you want to save? And then you can just press Y for yes.
Oh, I see. Yeah.
And enter, and then it should exit out of Nano for you. So
Plus
now
every future time we'll do save instead of name.
Yes, exactly. So now we should have, so now we've got our draft.txt, our draft of our thesis, which is going to be filled with award-winning content, I'm sure. So there are many other text editors. You're probably used to using some sort of text editor with a graphical interface. There's Nano, there's Vim, which David mentioned before, which is another one that's based on the terminal. And there are other fancier ones that obviously have graphical user interfaces that pull out of the terminal. Nano and Vim are kind of, I'm actually not sure which one's older. David might know. But, it's kind of much for muchness. They're the kind of thing that's useful for quick edits in a terminal, but you might find that, when you're doing massive edits of big text files, you want something which is a little bit more graphical. So yes, so now if we do ls, we have our draft.txt in our folder, which is nice. We've created our little draft file. And as David mentioned, this is not the only way to create a text file. We can also use the touch command. So we have a little exercise now. I'm going to give you just a minute or two to do this one, creating files in a different way. And shout out, as always, if you have any questions, comments, you found anything interesting, I always want to hear it. Okay, so hopefully this one shouldn't take too long to do. It's a pretty quick little exercise, and we've already seen the touch command. But would anyone like to volunteer for some answers here? What does touch do? And I will pick someone out if I have to.
Creates a new file. Oops, sorry.
Yes, amazing. That's okay. Overlapping voices is good. It means we're eager to learn. Yes, it creates a new file. Excellent. So next question, how large is my file.txt? Has anyone tried that out? I haven't, so I don't know.
0 bytes.
0 bytes. Excellent. Yes. And that's because touch just creates an empty file. So when might you want to create a file this way? I guess if you just wanted an empty file that you wanted to later fill. So there's some interesting ways to create different kinds of files there. What's in a name? Okay, so this is a little note in the tutorial. Again, we're talking about naming conventions. So everyone should be used to seeing .text files, .doc files, and if you're in Word, .powerpoint files. And really, it is just another convention, but it's a very, very strong convention that everyone likes to adhere to because it's useful. It's a useful way to delineate what types of files we're looking at. And it's also used by other programs often. Certain programs can only read certain types of files, so they will look to the file extension after a full stop in a file's name to see whether or not it's going to be compatible with what they can do, basically. Okay, so that's the first part of this lesson. Now we're going to learn how to move things around. So we're going to move back in our terminal. We're going to move back into the shell lesson data. Okay, so we should all be in the thesis folder at the moment. Can anyone tell me how I would get back to shell lesson data if I didn't know the full file path from here? Or if I'm too lazy, I don't want to enter this full CD desktop shell lesson data. What's a much easier way to do this?
You just do the 2 dots.
Dot.
Yes, 2 dots. Excellent. So we're back where we want now. And then we want to take our draft.txt out of the thesis directory and move it into the shell lesson data directory. So for this, we're going to use move, which is short for move, very original. So we're going to move. So we wanted the first argument to this command is going to be the file we want to move. So we know that that sits in the thesis folder and we know it's called draft.txt. And then we want to, okay, so here we're moving it, but we're moving it to the same location, still in the thesis folder, but to a different name. So here, this is really equivalent to just renaming the file. We're going to rename it quotes.txt. So now if we do ls and we want to look in the thesis directory, we will see we no longer have draft.txt, but we have quotes.txt. So this is the way you would rename a file in the terminal. It's basically, it is just equivalent to using the move command. What else do we need to know here? Okay, very important note we've got here. Move is one of these things that can act silently and cause problems if you're not too careful. So let's say I had a very important file. I'm going to make, what am I going to call it? I'm going to call it vip.txt, very important. Now, let's say there was something in there that might contain my passwords, or it might contain the entire draft of my thesis. And so I don't want to move it. However, I decide one day, I don't like this thing in thesis called quotes.txt. I think I should move it out to my current folder and I want to call it vip.txt. So if I do that, move says, yep, that's fine. I'm very happy to move this file. Move doesn't care that there's already a file there called vip.txt. So if I look at vip.txt using nano, we will see that it contains all of the content that was originally in quotes.txt. So this is just a word of caution. Make sure when you're moving things, you're not moving them to a file name or a folder that already exists, because that's going to cause problems. So now I'm going to move this back into my thesis folder, and I'm going to call it quotes.txt again. We do ls, we will see that we no longer have VIP in this folder, so we've moved it back. What else do we need to know in this tutorial? Okay, so this one here, so if we're doing move thesis quotes, and we want our second, if we make our second argument just the dot, what is that going to do? What is the dot as a file? Anyone?
It's the current directory.
Yes, exactly. It's the current directory. So now I am moving something from the subdirectory, which is down a level. I'm moving something from thesis quotes.txt into my current directory. So if we run that command and ls, we will see that now quotes appears in our shell data folder, in our shell lesson data folder. And now if we go into thesis, I guess let's just do ls thesis, we can see that quotes.txt is no longer there. So yay, we've moved it. And then, so this next part of the lesson is just if we try and move it again, if we say, I don't think that worked, I don't trust my computer, I want to move it out again, it's going to throw an error. It's going to say there's nothing in that folder called quotes.txt. Okay, moving files to a new folder. All right, so now we have another little exercise. So I'm going to give you all a few minutes to do this, and then we will chat about the solution. Okay, so we're not actually entering any commands in this one. We're just going to think about what we would need to do to move these files. Okay, so first question is, I guess, so we've got all of these files in the analyzed folder, and this command has changed us into the analyzed folder. Now we want to move a couple of files out of that and into raw. So what's the rest of this command going to look like? I would love a volunteer.
../raw.
Yes, excellent. ../raw, because that's going to move us up one level and into raw. Perfect. All right, so now what have we done? We've learned how to create files. We've learned how to move files around. Now we need to know how to copy them. So if we pull up our terminal again, this is another very useful function. I use it a lot. It's CP, which stands for copy, as you can guess. So if I ls, again, we've got my quotes.txt file in my current folder, but I want to copy it back to thesis. And in copying it back, I want to rename it to quotations. So I want CP quotes and then thesis quotation. Whoops, can't do tab complete for that. TXT. Now, if I look in thesis, I will see I've got quotations.txt. Excellent. Now we're going to use a flag with CP. We're going to use the R flag. And R stands for recursive here. So it just means that we're going to copy everything. We're not only going to copy the folder, we're going to copy everything in it as well. So I want to do CP, R, thesis backup. And then if I look in thesis backup, we should see exactly the same things that are in thesis. And we can look at thesis to compare. Excellent. All right, so that's copying. If there are no questions, we'll move on to removing, which is getting a little bit more dangerous, but that's okay.
Yeah, can you copy a directory without taking everything in it?
That's a great question. Why don't we try it? So let's say we're going to try and copy thesis, and we're going to copy it to thesis backup 2. Yes, so we're going to get an error, basically because the default pattern for CP is to assume that we're copying a single file. So it gets confused if it gets a directory without the R flag. So short answer, no, you can't just copy a directory name without all the stuff in the directory.
And do we know if the command executed successfully?
Well, so in this case, when we tried to just copy the folder, we know it didn't because we get this output. It's nice. It doesn't fail silently. I guess if if it's successful, then we won't get any output. So a lack of output is generally a good sign. And you can always double check it with an ls in the directory where you're looking for the copied things.
So when you type cp -r thesis backup, you don't know whether that worked yet?
Well,
So
well,
to
sorry.
come in on this one, I'll just jump in on this one. So short answer, the short answer is from your shell without just running as is. No, you don't really know. So you can run it, and if you get your next shell prompt, it's probably run okay. But a better answer to that one is that every Unix command outputs a signal when it's completed, whether that be like 0 or whether it's failed, and each of them have a specific set of error codes that they'll output. So what you can do is you can pipe the output of the copy command to some other command that either tests the output, checks that it was okay, or send errors to nowhere. And that way you can explicitly tell whether a command's run properly or not. Perhaps not helpful because most of the time with CP, it's going to be fine. And if it fails, it'll tell you if you get your next shell prompt, it's run okay. But if you want to know specifically, you can either read the I think there's a bash expansion that allows you to look at the exit signal of your last command. I'll check that one for you.
Cool.
So while David's checking that, do we have any other questions about anything that's happened so far? Is everyone following along okay? Yeah.
Okay, yeah, I do remember it. So there's 3-minute tangent. 3-minute tangent. So every Unix C command kind of has this output. So like if it exit with code 0, that means success, 1 is failure, and then there's like hundreds of these codes to say, I encountered a memory allocation error, or I encountered a file system error or something. And specifically the variable that bash stores, it's called $? So if Emily, if you type echo $? That's going to give you 0 because it says the output of the previous command that you ran was successful.
Very cool.
Yeah. And so that's how you'd specifically tell if you really wanted to know what happened. And say it gave you something other than 1, you'd be able to look up in the manual pages what that exit code meant.
Yeah, that's really cool. Thank you.
All good.
Amazing. Thank you, David. Okay, so in that case, we will move on from copying to removing. So removing, another very simple, very easy command to remember, it's rm. So what do we want to remove here? We want to remove quotes.txt. So we're just going to go rm quotes.txt. And now if we do ls again, we'll see that we have no quotes in this folder, which is exciting, I guess. And if you want to just confirm that it's actually gone, we can try ls quotes.txt. And we'll see no such file directory. If we try removing it again, we'll get, again, same error. So yes, a little note on deleting. This is why we say it's a little bit dangerous. Deleting is forever in the terminal. There is no recycle bin or rubbish bin that you can go to if you accidentally delete something. So it's always good to be careful about when you're deleting things. And that's just what this little exercise here does next, using rm safely. So if you want to give that a go quickly, and as soon as you've done it, can someone shout out what it does for me? Shouldn't take very long at all. So this is using the I flag with rm, which is always good practice. You should always put the I flag in.
it asks for confirmation.
Yes, exactly. So this is kind of like a fail safe. So if we want thesis back up, let's say I'm really tired one day, working hard, and I think, oh, I don't need this anymore. But let me just check, remove thesis backup, yes or no. So, and you can just type in, so no, I want to keep it. Or you could type in Y for yes, if you really do want it gone. So that's always a good fail safe for removing things. Okay, and then directories. So again, like CP, if we try and just remove a full directory without any kind of flags, we're going to get the error. This is a directory. So thinking back to CP, what flag would I use if I want to remove the thesis directory? It's going to be the same flag. Any ideas? How about Patrick? Have we heard from Patrick yet? What flag do you think I would use? No, Patrick's silent. Okay, that's all right. So we're going to use exactly the same flag. I would use rmr if I wanted to remove the directory. And if I wanted to check as well, I could combine both flags. And then it's going to ask me, and it's going to go through all of the files in the directory and ask me if I want to remove them. And I think, oh, I've got many directories in here. And I say, no, I actually want to keep that one. No, I want to keep that one. And then, yeah, I don't need thesis. That was a mistake anyway. So that can go. But we don't want to remove thesis. We want to keep it. So now if I look, I still have thesis. If I look into thesis, we will see that my silly directory that I made thesis is now gone.
So if you type yes for the last one, then it doesn't matter what you typed in all the previous ones, they'll be deleted anyway.
You know, that's a good question. You know what, let's try it. There's nothing particularly in there that I need. Let's see what happens. Okay, so we want to examine everything and we're going to say no, no, and then we're going to say yes. Okay, so we're going to get permission denied again, and this is because thesis is the folder, and that last command is functionally the same as just trying to do rm thesis. I'm guessing, although the output looks a little bit different.
It said it probably did permission denied because you didn't give it permission to delete the stuff inside it, right?
Yes, that would make sense.
So there's a couple of reasons for this one. So rm. So first thing is rm will not remove, unless you supply the -f -force flag, it will not remove a directory that has an empty, essentially what you can consider rm as like reducing the hard link count by 1 from 1 to 0. So say, so the operating system can collect the inode or whatever, but that's technical land. Basically, all the rm will only remove a file. It will not remove a directory with contents in it, unless you supply the -f flag, in which case it will remove everything. It would much rather you do rmdir, which would remove the directory, and remove directory would tell you, this is not an empty directory, are you sure you want to do this, type thing. If that clarifies things.
No, I mean, so you're saying just you shouldn't use rem for folders.
So you shouldn't use rm for folders.
Okay.
But everyone's just going to use rm-rf on to nuke things, and I use it more than I should.
Okay, but there's another one that's like remove.
Yeah, there's
dir or
remove
something.
directory. So technically what you're supposed to do is, best practice is you go rm this folder, remove all the stuff inside of it interactively, then call remove directory on it afterwards, to say, yes, I actually want to get rid of the directory. That's kind of like, if you do that, it's very difficult to make mistakes, but that's slow and painful, so everyone just does rm-rf that thing.
So remove directory only works on blank directories?
Yes. Well, it will work on filled directories, but it will only remove it with the default arguments on an empty directory or a directory with no contents.
All right. Then you probably use minus like -F or something.
Yeah, -F will just, I think, yeah.
Cool.
Does it completely get rid of it? Like if you went and looked for all the hidden files, there wouldn't be anything left.
Yes. So that's a good point. Often if you go try to remove things from a directory, it'll remove all the main files and it won't always remove the hidden files. And you'll go remove directory, this directory, and it'll say it's not empty, and you ls the directory and there's nothing in there, but there's still a few hidden files. Dot and dot don't count in this case, but if there's any other like dot bash profile or dot other stuff, that does count, and you will need to remove the hidden files as well.
Yeah, and when you go run thesis, it'll ask you about the hidden files.
Yes, which is a nice thing of doing it interactively. Whereas if you do it manually without interactively, sometimes it's missed. Or if you do it with glob expansion, which we'll cover in a sec. Good questions, guys. Good questions.
Yes, good questions. And thank you, David, for stepping in with all the expert technical knowledge. Okay, so David did just mention that it's bad practice to use rm on a directory, but here we are going to do it. Next step, we're going to do rmr with the recursive flag to remove the full thesis directory in the tutorial. So we do rmr thesis, and it's now gone from my directory. I'm just left with thesis backup.
And that only works because it's empty.
So that thesis directory wasn't empty there, but
it's the -r.
Yeah, it's the -r, which is for recursive. So that tells RM, look in the folder as far down as you can go, delete everything, basically starting from the bottom up.
So what were you saying about the need to use -F?
So rm-rf also covers a few extra cases of symlinks, weird hidden files and other stuff. So it's like rm-rf is the nuke it, I want it dead, whereas rm-r is like the plus kill everything type deal.
Okay.
If you can get away with rm-r, use it, but I think when you run into issues, just know that rm-rf is the nuke it, but be very careful when you decide to nuke things.
Cool.
Okay, excellent. So now we've learnt to create things, copy things, move things, rename things, remove things. Now we're going to look at how we can do this with multiple files at once. So I think we have, so we've got an exercise here. So I'm going to give you all a minute or two to work through this, and then we will look at some of the solutions. So we want to make sure, first of all, we're in our shell lessons data folder. So we're going to, if you're where I am, we're just going to cd into data. And then we're going to, I'll let you guys read it for yourself and work through some of it. Okay, so let's chat about this first one here. In the example below, what does CP do? When we give it several file names and one directory, after we've made the directory file, of course. We're going to make the backup. All right, so now what does it do? Has anyone tried it? If you copy amino acids and animals and backup, what do these three arguments do?
I got it that it wasn't an output. Is it? I just had a look and there wasn't a file.
There, as in
amino acids, but maybe I was not doing it right.
So you don't have amino acids in your data file at all?
It seems to have everything else, but doesn't have amino acids.
Oh, weird. Well,
It's got creatures,
yeah.
molecules, North Pacific, Jaya, Pizza, Solar. Anyway, doesn't matter.
Oh, that's
Oh.
possibly because you're in the one directory up. So you
Yeah.
might be in shell lesson data, but if
Oh.
if you CD into data, which is another folder inside.
Oh, okay, right.
So has anyone tried this command? Am I going to have to pick on someone?
It copies those 2 files into our new directory.
Yes, excellent. So basically how many files you give it as, whoops, not animal count, so you don't give it that directory. You want animals.txt, and then you give it the directory as the last argument. If you look in the directory, they will be copied into it. Okay, now what about this next example that we're given? So we're copying amino acids, animals, and morse.txt. What's going to happen there and why?
You haven't given it a directory, so it's going to throw out an error.
Yep, exactly. So we've told it to copy things, but not where to. So it just goes, what? I don't understand. And again, it doesn't fail silently. It gives us a nice error, which is, whoops, which is always good. Yep. So it's saying, hey, you haven't used the right syntax. You haven't used the right language. I don't understand. Excellent. Okay, so that's how to copy multiple file names, but that gets a bit tedious if you have 50 files in a folder that you want to copy to a subdirectory. So that is why we use something called wildcards, because when we're doing programming, we like to be lazy. We like to make our lives a bit easier. So the asterisk is what we call the wildcard. And this means that if we put it into a string, say, what's a good one here? Say asterisk.pdb, it can be expanded to one or more characters of any kind. So we're saying, in that case, we're saying we know we have files that end in .pdb, but we don't know what then we're called, and we don't care what they're called. We just want to select all of them. So this one's really useful. The other one that's useful is the question mark, which is going to match to exactly one missing character. So in this example up here, if you did question mark ethane.pdb, that's saying you want everything that has ethane.pdb plus one leading character, and we don't care what that one leading character is. So the shell is smart. The shell expands these wildcards for us. And the other good thing is that you can chain them together. So if you knew, say, for example, that you wanted everything that ended in ane.pdb, you can put in 3 question marks and you're saying that there are 3 characters at the start of those files and you don't care what they are. You want everything that has 3 random characters at the start and ends in ane.pdb. So now we have a couple more exercises for you guys to work through. Let's start with the first one, listing file names matching a pattern, and then we will discuss what kind of output we get in just a second. Okay, so for this one, we're going to, where are we at the moment? We're going to CD into the molecule. Oops, where's molecules? CD into molecules, which is, okay, one level up outside of data in the shell lesson data folder. So in molecules, we've got all of our molecule files. Now, can anyone tell me, we want to select in particular the ethane and methane files. So which of these options are we going to get? Which one's going to work to select out just those two from the 6 we have here? And I guess what's your thought process? Which letters are the same in both of them? Which letters don't we know? And how are we going to use wildcards for those? How about Angus? Are you around? I don't think we've heard from you yet.
Yeah. So for the first one, for the first one, it'll show all the file names matching 0 more characters up to T. And then following that, it'll show all the characters up to ANE. So then in our LS, you'll get ethane, methane, octane, and pentane.
Excellent. Yes. How about the second one?
With the second one, similar to what I said just before, it'll show all the characters up to T, then followed by the question mark. It will give you it matches exactly one character, and then so then in the end you get octane and pentane.
Yep. Nice.
Yeah,
please.
Do you want me to go for the third one, or
go for it?
Oh geez. All right. So same thing, obviously with it's pretty much the same thing as before, it just has an extra question mark on the end. So then in the end you get ethane and methane.
Yes. Yes. Very nice. Excellent. And the fourth one in there is a little bit boring at the moment because all our files end in .pdb, but let's say I was to make another file that was ethane.txt. If I was to do that last one now, ethane wildcard, it's going to pick up both files that have ethane in the name. Excellent. Okay, then we've got another exercise. So here we're going to be organizing directories and files. So this is just one that we're going to think through. I don't think we actually have the data for this, but then we will chat about solutions in just 30 seconds or so. Yes, and I just saw Patrick put 3 in the chat. Yes, good job, Patrick. Thank you. Correct answer. Okay, so for this next exercise, we have a certain directory structure at the moment given by the output. So we've got 2 folders, analyzed and raw, and we also have 2 files, fructose and sucrose.dat in this folder. So we want the output given in the second lot of little text boxes here. So I don't want to give it away. I want to ask you guys, what kind of structure do we want our directory to have based on this output? Maybe Jordan, you around?
Yep.
Excellent.
What was the question, sorry?
So what kind of directory structure do we want if for the output of ls we get just the 2 folders and the output of ls analyzed we get our .dat files? How do we need to change our structure?
So you need to put the 2 folders into analyzed. So you could do move and then type in each of the files, then the directory analyzed.
Yes, excellent. Yes, please.
So do it with wildcards. So
Yeah.
you can match. You could do the star one, which matches any character.
Yes.
And then .dat analyzed, and that'll move all of them.
Yes, excellent. So yes, it would look something like moved star.dat analyzed, which obviously I can't type in because we don't have these files. It's going to get upset with me, but that would be the command you would use. Excellent. Okay, then what are we doing in this next exercise? We are starting a new experiment and we want to copy a directory structure. Okay, I'm going to give you a minute to do this and then we will chat about how you go about reproducing this structure. Okay, hopefully that's enough time to read through it. So basically we have this output at the top. This is our directory structure that we want. So we've got our parent directory is the date, and then the little branches indicate the child directories. So we've got inside our directory named by the date, we have a data directory, and in that we have two further directories, raw and processed. Oh, well, that's what we want. So the question is, which of these 1, 2, 3, 4, 5 options in bash are going to give us that directory that we want? Let's try this with reactions. Let's see if this is going to work. So can we get what can we do? Can we do thumbs up and thumbs down? Let's see. Let's do thumbs up if this option is going to work, and I don't know, something else. I can't see if we have a thumbs down option if it's not going to work, or like a red cross if it's not going to work. What do we think for this first one? If we have make directory, yep, thumbs up. Yes. Excellent. I'm seeing thumbs up. Thumbs up are good. Yes, more thumbs up. Amazing. Yes. So this first lot is going to give us what we want. We're making the parent directory for the date, and then we're using absolute file paths to make the subsequent child directories. How about this second option? If we are hopping in and out of directories with makedir and cd, is this going to give us what we want? 1 thumbs up, 2 thumbs up, 3 thumbs up. Are there more? I possibly just can't see them. Yes, many thumbs up. Excellent. Yep, this is also going to give us what we want. Perfect. Okay. How about this third option here? Is this going to give us what we want? Thumbs down. Thumbs down, thumbs down. Does anyone want to explain why thumbs down? Why is this not going to work?
It's just going to give an error.
Yes, exactly. And why is it giving an error? What have we forgotten to do if we were trying to do this?
It's trying to create a new directory inside a directory that doesn't exist yet.
Yeah, exactly. Yes. So makedir is not quite fast enough. It's not quite clever enough to create these directories that don't already exist for the layers above, the one we're ultimately trying to create, so raw or processed. How about if we use the P flag? Has anyone tried using the P flag? Is this going to be a thumbs up or a thumbs down? Thumbs up. Do you have any more reactions? 2 thumbs up, I see. Excellent, yeah. And so if we look at the man page for, makedir, we will see the P flag, yes, thumbs up. The P flag creates an intermediate directories that are acquired. So this is basically going to make the option above work, adding this flag here. Okay, and then our last option, is this one going to work? If we do makedir, change into it, makedir. No, I'm seeing thumbs down. I like thumbs down for this one. Excellent. Does anyone want to explain to me why? Are there going to be errors?
No, but folder data and raw are gonna be in the same level now.
Yes, exactly. So there's nothing actually technically wrong with this solution, but it is going to create data raw and processed all inside this date directory instead of raw and processed inside data. Excellent. Nice job, guys. Okay, so now we're going to move on to a little note on creating multiple directories at once. So again, you know, if you need to create 3 or 4 different folders, it can get tiring. You know, my fingers only work for so long. They're going to get tired typing out the same lines over and over again. So we can chain together the creation of multiple directories using our curly braces. And of course, the P flag, if we're not sure whether the parent directories exist or not. So let's say, where am I? Let's get out of molecules. Let's say I'm now in shell lesson data and I want to make a couple of directories. I want to make a directory called observations. Inside that, I want to have raw and processed data. So I'm going to put raw and processed in my curly braces. And what did I forget? I forgot the P flag. So I'm going to add the P flag in to make sure that I get my observations folder made. And now if I look in observations, I'll see that I've got my 2 new folders, processed and raw. So that just saves a bit of time, you know, allows your fingers to be a little bit lazy, which we always like. So they're the main points in this lesson. Does anyone have any questions at this point before we move on to the next one? I'm assuming silence is a good sign here. So I will stop sharing. But what do you reckon, David? Should we take maybe a 15-minute break? Give everyone a chance to stretch their legs?
I think so. Get some food.
Yes. Yep. I agree. So
Drink some water.
yes, hydrate, walk around, stretch your legs. So let's come back here. What time is it in Perth, David?
It is 11:54, so I'd say come back, say 12:10.
Yes, excellent. See you all at 12:10.
AWST.
Yes, AWST.
And
Thank
if you have any questions, put them in the chat, or and I will either Emily or myself will get to them.
All right, see you all in a minute.
The fact that there are more than 2 cameras on, which is a good start. There's another one. So we're going to be going over, this is going to be number 4, so that we are going to go over pipes and filters. So if everyone wants to navigate to the pipes and filters page, I'm assuming you're all going along with that. So on the outset, the concept of like a pipe and redirecting output streams and everything seems a bit abstract and obtuse, but in my opinion, the concept of a pipe is what made Unix as an operating system kind of work. It's what, you know, I think if you look at the history of Linux and Unix, and you look at the guys who are building it, you know, I think Ken Thompson or whatever had to have 3 goes of making the first bunch of C and had a number of iterations of the operating system. And the first iteration of Unix that he was happy with was the one where he invented a pipe, and it's just all of these programs and functions and functionality just kind of can happen. And, you know, I think we've lost it a bit in the modern era with how we're doing everything via web transactions and stuff. We've lost this kind of text processing route, but I think it's still very, very important to understand where this came from. And you'd be surprised at the kind of dumb things you can do just because you know how to pipe the output one command into another. So let's start by heading into clear our terminal. Let's head into molecules from our lesson data. So we have those 3 PDB files. So if we remember the word count command, or WC, let's just check out man WC. So this prints the new line word and byte counts for a given file. So for example, if we go cat codebane, we see we have a number of lines and a number of formats. And if we were to go word count, we get
Are you sharing?
Yes, that's a very good point. My bad. Thank you. That's better. So yeah, man word count is a thing, and if we go word count codebane, we get 20, 156. So 20 lines, I think 156, and then there's like 1158 characters. I forgot 156, is that columns or something? Oh, new line word and byte count. Okay, 156 words. Cool. So we can do just count the number of lines with -L. So we have 20, and we can also do it for every single file in the directory with star.pdb. So that glob will expand to all of the directories, and we get this nice little summary of the number of lines in all of our files. So that's all well and good as a command line output, but what if we wanted to store that somewhere, or we wanted to look back, or we didn't have to run this command every single time? Because if we had hundreds of thousands of files, this command might actually take quite a while to run. So we can actually store the output using the angle bracket. So this angle bracket kind of says redirect the output of this command to a file. And so in this case, I'm going to give it a file name, length.txt. So now you notice we actually got no output on the actual command line itself. But if we look at the lengths file, it has the output there for us instead, which is pretty cool. A note on cat is that if you were to cat a particularly large file, it's like if we were to, do we have any examples of large files? If you were to cat a particularly large file, it becomes kind of like the man pages. So actually, yeah. Kind, okay, that didn't quite work. But if it's particularly large, you can use different keys to navigate. So yeah, that's the first really word count, or the WC command is the first very cool command. The next command is going to be the sort command, and the sort command is a little bit more interesting. So if let's check out its man page. And so you'll notice we have sort line of texts, and there's a bunch of different options. So let's go back to our lesson data. And the one we're going to worry about is numbers.txt. So let's have a look at numbers.txt. So I'm going to, you'll notice at this point we're at an exercise. So I'm going to let you guys have a look at this exercise and try and figure out what the sort command does. Does anyone wish to volunteer before I start picking on people?
Yeah, it orders them based on their numerical value.
That seems pretty correct to me. So if we go sort-n on numbers, it's sorted in numerical order. That's pretty nice. We're just sorting it in numerical order. So we can apply the same thing to our lengths.txt. Did I go to the right place? No, did I go to the right place? Yes, CD molecules. Okay. Where is it? Yeah. So yeah, lengths.txt. Great. So now if we run sort against lengths.txt, we notice that all of the lines of the file are sorted very nicely based on basically their line count, which is very cool. And then we could also pass this to the output of another file itself. So we could say sorted lengths. which is also pretty nice. And so you'll notice that I've changed the file name there. So if we redirect to length.txt itself again, you'll notice that it kind of messes up a bit and doesn't really know what to do with itself, and it kind of implodes. So don't redirect to the same file name. And so, yeah, so we'll just run that again, and we now have our length back, which is cool. So you'll notice that if I run this command repeatedly, actually no, we'll do this. If I run this command repeatedly, you'll see that the length.txt file isn't changing. But if I change this single angle bracket to a double angle bracket, you'll notice that when I run it, we're getting more output each time. That's because the single angle bracket means, create the file and put the content in, whereas the double angle bracket here means append to the file, to the end of the file. And that's a very important delineation, start from scratch in the file, append to the file. So I'm just going to get rid of length.txt, and then I'm going to, so in the case where you're creating the file, append and the two brackets will mean the same thing, but if you have an existing file, the append, so if we go cat length.txt, yeah, we're back at the normal. And so that's going to be a pretty interesting thing. So I've kind of given you the answer to the next exercise. So does someone wish to have a look at does someone wish to work through what does double angle bracket mean? Anyone? Okay. Well, I think I'm going to pick on someone who hasn't been picked on yet. I'm going to pick on Lara this time. Lara, could you tell me the answer to the appending data section? We'll work through it.
Oh, that one. Sorry, I haven't read that one yet.
It's all good. Do you have any thoughts on it?
I have a question about appending because I'm a little bit confused.
Sure. What's
so
up?
We're adding hello to a file, so we're creating test file one, and I'm guessing the appending stops you from overriding a file that's already there, and you
Correct.
add another file. So would the same thing also be able to be done if we just did echo hello with the one arrow to just test file 2.test?
Yep, absolutely. So if it's a new file that doesn't already exist, single arrow and double arrow do the same thing. They just create the file and add to it. But the special case is that with the single arrow, it will always overwrite the file and start from scratch. Whereas with double arrow, it will append to the end of whatever content's already there.
Okay, so if I had more data in one file, it would just add on to that data,
Correct.
but then create a new file and not delete the old file.
Would you go over
Does
that
that make
one again?
sense? So if I had like a really big set of data and I wanted to maintain that old format, but I wanted to add something new, then I could use the double arrow to create that new file with all the old stuff in it, but modified, and then also keep my old file as well.
So what you're saying is you want to have, so for example, let's say I have the length.txt here. You want to keep the original length.txt, create a new file that's a copy of length.txt and add an extra line to it.
Yeah.
So that can't, so you could, Ooh. So you can't do that with a single. I don't think you can do that with a single this command because you have to specify a single file. So what you
But you can do it with the double.
yeah. So
Okay.
the way I do that is I'd say you could say what would be the best way to do that would just be to copy lengths.txt to like lengths2 and then append to the lengths2 file.
Oh, okay. Yep.
Because this one, so what I say is that if the file didn't exist beforehand, I see that's probably not entirely clear. So basically you give the double arrow will expect a single file name like elder.txt or whatever. And if that file exists, double arrow appends to the end of it. If that file doesn't exist, it'll create it and append to the end of the new file.
Okay. Yep.
But you can't use it to create multiple files in this context.
Yeah, it just copies the data onto a new file essentially.
Yeah, it just adds whatever whatever the standard output of the previous command was. So you notice that with our word count -l start PDB, that this is the results that we're seeing here are the standard output of the word count command, and all we're doing with this is we're saying redirect the standard output of that command into a file instead of to the terminal.
Yeah. And if there's a file already existing, I could also add to that file by using the append.
Yes. Yeah. So you're just saying that's literally all we're doing. We're doing output redirection.
Okay, cool. Thank you.
All good. So have we had a thought on the appending data command?
Yep. So that would just be printing the first 3 lines of animals.txt and then the last 2.
So for that one, which one of the 4 options is correct?
3.
Good one. That is correct. Thank you very much, Sarah.
When I do sort without -n, it still sorts it numerically.
So this is a that's a bit of a we are getting away with a few edge cases here because the line lengths aren't terribly different. So for example, if the some of the line lengths were much shorter in your standard string sort, it would be preferenced higher or lower. So we just say we add the -n to ensure that it's just going on the numbers and not anything else. Because at the moment we're just getting a bit lucky that it's sorting it in the right order. Because if we added it in some, like what would an edge case be actually? That's a good point. So if we were to, if I was to add, say, thing. And I go, you'll notice that R will come out last. Whereas if we go sort -n, we get it in the right order.
Okay, so numerical sort puts words first.
Yeah, I kind of made it. So numerical sorts puts the lowest number first, whereas regular sort will put the lowest letter string first.
Oh, I see, but I have to add in some text to be able to see that difference in the order of the numbers.
Yes.
Okay.
Yeah.
Oh, I see why. It's because there are spaces at the start.
Yeah.
Is it of the file names?
Yep, that's correct.
Oh, not file names, but the output.
And so it's kind of an interesting thing is that the standard output of word count is purposefully designed to be passed into tools like sort and everything. So it's formatted that way nicely.
Wait, so is it because file lengths.txt has spaces at the start of the lines because that's how the command formats the command WC formats it.
Yes. So so actually what's happening is, so sort internally works off a delimiter system. So it sorts data by columns. And so by outputting a space at the start of word count, it's kind of letting sort know that this is a space delimited output. And so it uses spaced searches for the columns. And so at the moment, I'm not sure if the default behavior is to sort by the first column or the whole string per line, but I think that's one of the internal reasons. It's just for delimiting reasons. If that helps.
Mm-hmm.
So the last bit we're gonna cover is piping or combining multiple commands. So you saw before that when we were doing an arrow, we were redirecting the standard output of our sort or our word count command to a file, but we could also output it to another command. So we could go word count -l star b. We could also redirect it. So instead of redirecting it to a file, the pipe character redirects it to another command. So we can pass this to sort -n directly, and instead of having to pass it to a file first. Or we could say, let's go sort -n lengths.text, and we pass that to head, and we just want to view the first result. And that's kind of where things start to get very interesting, because now we can go, well, let's word count by lines our star.pdb, and then let's sort it numerically, and then let's just view the most important one, the lowest one. And then we can change it to be by words, or we can change it to be, I think, -c by characters. Yeah, by characters. And we can view the top 3, and then, it starts getting very, very expressive very, very quickly with the kind of questions that you can answer. I generally find it's not about, what does this command do? It's like, what's the question you have, and what's a series of commands that can answer that question for you. So we're going to go through the last sets of exercises. So there's, I think, 4 of them. And I would like to ask for a volunteer for the first one, which is piping commands together. Anyone? Okay, then you're forcing me to go on the journey. So, Brittany, I don't think I've heard from you today. Are you there? Maybe.
Sorry, I got to unmute my microphone.
Nope, that's all good. Could you please tell me what you think the solution is for the piping commands together section?
Okay. So I think that it will be, so trying to find the 3 files which have the least number of lines. So we want to look at all 3 files. We want to specify at the end that we want to look at all 3, and we want to sort them. And so I'm guessing it will be 4, because we'll be passing it to sort, and then after we've sorted it, we want to print out from top to bottom, so that's head, and then the 3 files that we're looking at, and then we'll see how many lines there are in that command. If that makes sense.
Yep, that seems pretty correct to me. Good job. Thank you very much. So I alluded to it a little bit earlier, but all of the standard Linux tools, or almost all of them, follow this philosophy of they do one thing really, really well in sorted. Like word count is very good at counting the number of characters. Sort is very good at sorting files. Head is very good at cutting down output. LS is very good at listing directories. And what allows you to do complicated, meaningful tasks is the ability to compose these programs together. And so you can redirect their output to files, or you redirect their input to the their output to the standard input of other commands. And all of the commands by default accept input from the standard input and pass it back out to the standard output. So when I actually run word count, so if I were to run cat this string, what's actually, okay. So if I actually run that, and I could actually give it some, okay, never mind, that's not what, but I could give it some standard input and it would read it from the standard input and throw it to the standard output, and the shell or our command interpreter is just a way of passing it nicely between the standard input and outputs. Otherwise, it'll just read it from commands. And this is kind of called the Unix philosophy. Go look it up. And I think it's why Linux kind of lives on as an endearing operating system that runs most of the world's infrastructure, because it's started with this, and it's very cool. So for the pipe reading comprehension exercise, do we have any volunteers? No volunteers? Okay, that's a shame. Abraham, I'm going to pick on you today. So could you please tell me what you think of the pipe reading comprehension question?
Sorry, I'm a little bit lost. What question were you asking me?
So we are near the bottom of the pipes and filters section.
Yeah.
There's that orange box labeled pipe reading comprehension, which is a question.
Got it. Yeah.
And that's what we're on.
So the first command just to extract the first, the first 5 lines, but I can understand, and then the last 3.
So we are catting out the file, so that's going to give us all the results. Then we're passing it to head-end5. What will head do?
Give you the first 5 lines.
Yep, first 5 lines. Then we pass that to tail-n3. So what does that do?
The 3 last lines, and then it's going to sort it out in reverse.
Yep. So we're going to get the first 5 lines out, then we're going to get the last 3 lines of that. So
the last 3 lines.
So we're going to get, which lines are those going to be?
The last of the first 5 lines, but put it in reverse order. So it's from the it's alphabetic order.
Yes, so this one will be in alphabetical.
Okay. Okay. Yeah.
So we should get, well, actually, technically it's actually going to be numeric first, because it's going to look at the whole string by default.
Okay.
So we're going to get the 11-06s first, and then we'll get the -05 as the last one.
Okay. Oh, I see.
So what we get is we get rabbit first, then deer.
Then raccoon. Okay. Yeah, I got it.
Yeah, and that will be that one. So we only have 3 more to go. I will get through all of you eventually.
Can I just ask a quick question?
Sure.
So I mean, the commands are just telling you to initially take the first 5, which is just in as per listed, and then the effectively the last 3 of those 5, and then order those 3. So it's just going to be whatever order they're in, isn't it, rather than any particular property of the line itself? Is it the fact that it was raccoon, rabbit, and deer, initially, oh, sorry, so it has, no, I missed that bit at the end. It has actually taken me.
Yeah, it's got the sort command there
Yeah,
as
yeah,
well.
sorry.
No,
I missed that.
it's all good. It's a bit of a tricky one. So, does anyone want to have a tackle at pipe construction, or am I going to have to start picking on people again? Daniel, how about you? I haven't heard from you today. Are you there? Maybe, maybe not.
Oh, so Daniel just put in chat. He's having issues with his microphone.
Ah, that's all good. Yeah, I can't quite see chat. That's all good. Who else have I picked on today? Patrick, you're next. Can Patrick hear us? Can't see. I don't think Patrick can hear us either. Okay then. I guess we'll have to keep going down the list. So after Patrick, I can't pronounce Anongas. He's probably
Yeah, Angus. Yeah.
Oh, sorry, Angus.
Yes. So would you on the end of the cut flag D, flag F animal text command, would you put the unique command after that, followed by sort, or would you do sort then the unique command?
So for this one, I do sort first, then unique.
Yeah, gotcha. And then you would get, if you do that, you get then the file says bear, deer, fox, rabbit, raccoon.
Yep, and that seems to be right. That looks correct to me. It's yeah, whether to do sort or unique first is it's a bit of an interesting debate because they kind of, it doesn't really matter what order you put them in, but it depends on, I can't remember which. I think there's a reason why one of them's faster. I can't remember which though. So that's, you know, if any of you are particularly interested, there is some good blog posts on why you should do one way or the other.
Does unique just delete duplicates?
Yes, unique just well, unique also does other things. So if we have a look at the unique command. So yeah, that's right, the adjacent. So there is I believe there's a behavior for unique where it doesn't do adjacent ones, but essentially if there's you sort it first, so all of the same ones are clumped together, and then unique will cull the repeated lines. Yeah, you are correct. Thanks for that one. So, well, Aiden, seeing as you've kind of come up, would you like to volunteer to do which pipe? That question.
Okay, sure. I'm just
There is
reading
no
it.
escape. If you talk to me, you'll be asked for questions. If you don't talk to me, you'll be asked for questions. I will ask you a question.
Yeah, I'm just reading the question.
It's all good. It's good.
Okay, so we need the total count of each type of animal in the file. So we're going to need to use unique minus C. That will give us the, wait, what? Let me just think. So wait, what was the cut minus D comma? Don't you need to specify what the delimiter is?
So the comma is the delimiter.
Oh,
Yeah.
okay.
Yeah. It's a bit of a trippy one, honestly, and there's different ways for specifying the delimiter. I think you can do it with like D equals something. So that is a bit obtuse to read, but they are specifying the delimiter there as the comma.
Okay, and that'll just delete the rest of the line after the comma.
Well,
it won't be the output.
Yeah.
Okay, so we'll start with doing that.
And then, as you said earlier, we need unique only removes duplicate lines if they're right one after another. So we need to order up all the lines, right?
Yeah, so I guess we'll sort before we do unique, probably.
Mm-hmm. So which of the 4 options you think looks the most correct?
I'm just trying to remember, what is the minus F to animals.txt?
So that's all part of the cut command. So the -F tells you which field or like which column. So you can imagine if we have the so I'll do it in
I think I get it.
Yeah, I think you get it. So where is it? So for those of you following along at home, so if we have a look at animals.txt, we get this, and if we were to pass this to cut -D, -F2, that just gives us the second column. It's as if you've split up the file based on that comma, and then we can pass that to sort. And then, so we have all the duplicate lines are put next to each other, and which is the last command we need to run, Aiden?
Sort and then unique. Yeah.
Yeah, sort and then unique.
And that'll be done. So D. 4,
Yeah.
I should say.
And that's correct. That's where we're at. Very nicely done. That's quite a tricky one, to be honest, because there's a lot of new commands to be thinking of. And for the last question of the exercise, why don't we put this one on Emily? See what you think.
See what I think. Okay, so what are we doing for this one? We're removing unneeded files. This one?
Yes.
Okay, so you want to delete your processed files and only keep your raw files and processing scripts to save the storage. The raw files are in DAT, processed files are in .txt. Okay, so we want to delete the processed files, which means we want to delete things ending in .txt. Now, so that means we don't want number 4 because that's just going to delete everything with a dot in it. So we want something from 1 to 3. And then, so we don't know how many letters are in our files. So we can't use 1 because that would just assume our files have 1 letter in their name before the .txt. So it's down between 2 and 3. So we're going to go with 2 because that's going to select out everything with any file name ending in .txt of any length. And what would 3 actually do? I don't.
So 3 has a space in it.
Yeah.
So what it will do is it will remove everything, and then it will attempt to remove the random hidden file .txt. So that's the curse of the space.
Yes.
And so that's a basic introduction on how to use pipes and output IO redirection. I think this may not be entirely useful for all your projects, but just knowing it is and being able to quickly do something that would take a really long time otherwise is a superpower in my mind. So I'm going to pass back to Emily to handle doing loops in Bash.
Great, thank you, David. So, all right, we're on to the next lesson, loops. So I will share my screen again. So loops, this is something you've probably come across if you've done any other kind of programming in your favorite programming language, whether that be MATLAB or Julia or Python or C. Everything tends to have a loop. So today, though, we're going to learn how to do them in Shell, because that can be a very useful thing to do. This is much like the last lesson, as David was saying. These kind of things are going to help you make short little scripts that make your life easier. Because we like being lazy. We don't want to have to write things out a million times. And this is one more way to cut down the number of lines we have to write. So the general structure of a loop, or its syntax in Bash, is for thing in list of things do. And then we have our operation that we're going to be doing. And then at the end, we have to tell the shell that we're done. So if we don't do that, it's going to keep waiting for us to tell it what to do next. So we need a for, do, and a done that we're looping through. So if I open up my terminal and I make a for loop, let's just say let's do a classic for I in 1, 2, 3. And you'll see that when, oh, did someone have a comment? Nope, we're good. Okay. You'll see when I have entered my first stage of the for loop, my prompt changed. So it changed to this angle bracket, which we saw before. When we use it, it's to pipe data from one, or to pipe output from one command to another. But in this case, the shell has changed the prompt on its own, and that indicates that we're inside the for loop. So we have to tell it to do something here. So we're just going to say, let's say do, and then we're going to go with echo. So I think we've seen echo at various points throughout the tutorial today, but basically echo is the equivalent of print. And then, so we're telling it we want to print the variable I, so we need to use the $sign to tell it that we want it to print a variable and not just I. I'm going to say we're done, and yay, it prints out 1, 2, 3 as expected. And you'll see once we've done the for loop, the prompt changes back to our regular Bash prompt, whatever that may be for you. Same symbols, different meanings. Yeah, so I guess the other thing to note, I mentioned this briefly. So we use the $sign in for loops to indicate we are referring to a variable I. So if I didn't put the $sign there, it's just going to give me I 3 times, because the shell doesn't know that it's a variable. The shell just reads that as basically just a string. So the $sign is kind of useful in general. The other thing you can use it for, you'll have some environment variables that are set as part of your shell. So David talked earlier about how we can do cd tilde to go home. The other thing you can do is, you can do cd home, and that's going to take you to exactly the same place. Because that's just another alias, another variable that points to your same home directory. And there are a couple of others of those that you might find useful throughout your projects. There are a couple that we'll be using on Cytonics in some of our workshops later in the week. So it's just good for you to recognize what these variables are now. But let's go back to our folder that we've been working in. Let's see if I can remember where it is. There we go, shell lessons data, lovely. Okay, so now we're going to work through some exercises on, what are we going to be working in? We're going to be working in the creatures directory, I think. We're going to cd into creatures. If you're not already there, make your way there. And you can see we've got 3 files in here, 3.dat files. So the first thing we want to do is we want to loop through all of these files. So for x in Basilisk, and I'm lazy, I'm just using tab complete because I don't want to type it all out. So we're going to say for x in each of these 3 files, do, and then we've got our head piping to tail here. So head lines 2, and we need to use our $sign, say we're using the variable x again, and we're going to pipe that out to tail, and done. So that is going to print out the second line of each of these files. So if we look at Basilisk, it's going to be quite long. If you look at Basilisk, you can see the second line up here. We've got first line common name, second line Basilisk vulgaris, which is indeed exactly what we printed out to the terminal. So The other thing, well, I guess just the other thing to note is this X doesn't have to be called X in my for loop here. You could name it anything. You could name it blah. You could name it temperature. You could name it Sandy if you want. But it's good programming practice to name your variables something that makes sense to you, because you don't want to come back in 6 months' time to something that you've written and not understand anything because it's all named after members of the Beatles. So now we have a little exercise doing variables in loops. So we should be in the molecules directory now. So we're going to cd out of creatures and into molecules. You should have all of your nice files there. Okay, and I'm going to give you a minute just to think about the output of each of these for loops that we've got in these questions here. Okay, so would anyone like to take a stab at the first one for me? How about Helen? Would you like to do this one?
I haven't quite done it, but I'll take a stab at it.
Yep.
So it's going to go through and for the first 5 letters of, is it the letters or the actual objects? Sorry, I haven't run it yet. But
no, that's all good.
It was just I was trying to change directories and things.
Oh, no worries. So we can run it together if you want. So we've got,
yep.
So we've got for data file in. So first of all, what's this going to do? Which files is this going to select? If we're using asterisk.
Yeah, all the PDB ones.
Yep. Excellent. And we've got do, and then we want to ls. So we're LSing, and then what are we listing if we're using asterisk.pdb?
So it's all the files with the PDB.
Yes, exactly. So basically, we're just printing out the contents of the directory the same number of times as there are files in the directory, as there are .pdb files in the directory.
Yep. All right. Yep.
Sound good?
Yep.
Excellent. Now, do you want to have a stab at the next one and how it might be different?
So do you mean the for loop?
Yeah, just the next for loop on the page.
Okay. So for this is just a contained thing, is it? It's not in one of the files. Okay. So for each, I think it's probably asking for each character, is it? Do operation using.
So we're looking at this second one for data file. It's still the for data file in asterisk PDB, yeah? Just the second one.
Oh, sorry, I was looking at for thing in list of things.
Oh, sorry. So we're up to variables in loops, the little exercise.
Oh, right. Okay. I was looking at completely the wrong thing.
All good.
All right. So you mean the for loop, the data file?
Yeah, for data file in asterisk, do ls data file, that one.
Okay. So it's the list the data, list each version or anything that ends with the .pdb.
Mm-hmm.
So the data file is just the iterator.
Yes.
And so it's anything that's got the .pdb extension.
Mm-hmm.
Yeah. For however many there are, rather than keeping. Well, actually, usually a for loop is within a certain amount of iterations, isn't it? Rather than just, because that's more a while loop, I would have thought.
Yeah. So I guess the difference is here. So it is a set number of iterations. We as the human don't know how many there are, but the shell is going to know how many there are because it's going to look at all of the files that match that wildcard, the asterisk.pdb.
Yeah.
And so it's going to say, okay, there's actually 5.
Yeah, because when it's written like that, it actually looks more like the way you'd write a while loop rather than the way you'd write a for loop.
Yeah, that's interesting. I guess, yes, just because we don't necessarily know how many .pdb files there are. Is that what you're thinking?
Yeah, yeah. I mean,
Yeah.
I obviously the keyword in is
Yes.
an indicator, but yeah, just usually you get the you specify the amount. Anyway, it doesn't matter.
No, it's all good. I mean, it's good to clarify these things. Yeah. So I guess the point of this wildcard is even though we don't know the amount, the shell expands that wildcard and it works out the amount.
Yeah. Okay.
Yeah. So in this case, yeah, we're just going to list all of the files once compared to the last one where we list all of the files all of the times.
Yeah.
Right, excellent, thank you. So now we have another exercise and we are limiting sets of files. So what would the output of running the following loop director in this directory do? I'll give you guys a minute to think about that and then we'll chat about it. And maybe think about both. Think about what the first one does and how it's different to the second one.
So for the previous question, where it says ls $data file.
Yes.
Could you just is that the standard way to print what's contained in a variable using ls?
I guess I mean, you could also use echo, right? That would print the content of the variable as well.
Okay.
I guess in terms of what's standard, I guess ls assumes that it's a file or a directory. Whereas echo, the variable can be anything. So we're using ls here because we know we're listing file types. But if you were just listing variables that were something else and not a file, then I would use echo instead.
Okay, so we could just do echo there to work in general.
Yeah. Okay, we had a thought about limiting sets of files. Would anyone like to volunteer or will I pick a name?
I can do it.
Amazing. Thank you, Lara.
Okay. So for the first one, it's just doing pretty much the same as the one before, but only for ones that start with C and have any number of letters after it. So only Cubane would be listed.
Excellent. Yep.
And then for the next one, it's also doing that any number of letters before the C could work. So Cubane and Octane would work.
Yes. Yep. Very nice. Perfect. Okay, so that's the main structure of the for loops. Then we just have a little note here on globs and why they're good. And basically it's, it's what I was saying before. We like to be lazy if possible. And globs make life easier because you don't have to type everything out. It's really all we're saying there. So now we're going to use what we've just learned with for loops and combine that with the previous lesson with piping output, and we're going to save some output to a file. So I will give you another minute to work through this one, because you should be able to do this one. We have all the right files. Yep, we have all the right files. So give it a go, and then we're going to talk about what you get. Okay, would anyone like to volunteer? Have we got this running? How about Ethan? Do you want to give this one a go?
Yeah, so for this one, the correct answer is number 1, because it's using a single right arrow thing instead of 2, so it's going to overwrite the file every time, and only the last iteration of the loop will actually be saved.
Yes, very nice. Excellent. And so because we are all experts on piping and appending, we're going to, well, yes, this next exercise is almost exactly the same, except we're using the double arrow. And as Ethan rightly pointed out, single arrow is going to overwrite, whereas double arrow is going to append. So that's all that's happening there. That's not a particularly exciting variation. So I think we can move swiftly on through that one. And now we're going to have a look at slightly more complicated loops, using slightly more complicated functions. So the example we've got here, so here we're using the echo function to print out our file name. So we're going for file name. Are we in the right? No, I should be in creatures. Okay, so we're changing out of molecules and into creatures. Now we want for file name in all files ending in .dat. What do we want to do? We want to echo the file name so we can see what it is. But we could also, of course, do ls here because we're looking at files. And then we're going to do head N100 of the file name. And of that, we want the tailing 20. And so we see that for each file, so we've got the file name printed out, and then we have the last 20 of the first 100 lines. So lines 80 to 100 printed out, which, it's just lots of genetic code, which unfortunately I cannot read, but that's okay. We know we can do it. Yes, so I've already mentioned echo. Echo is basically the shell equivalent of a print statement. You can, whoops, shouldn't use special characters. You can use it to print out anything, print out variables to standard output. You can use it to print out strings, as I've done here. It's just a handy little one to know. And then what are we doing? So we're doing same thing again. Okay, so the only thing that's different in this one is basically we don't need to have echo. We can just have $ file name, and that's going to print out the same thing. So spaces in names, related to this is apostrophes, which you saw me muck up a little bit earlier when I tried to echo how's it going.
Sorry, before you go on to
yeah, please.
Spaces in names. This, when it says the echo prints its command line arguments to standard output.
Yes.
Oh, sorry, I get what it's saying now. I thought that was related to the thing above it.
Oh, no, all good. Yeah.
Okay.
So
yeah, okay, cool.
yeah, all good.
All good, all good.
Okay, cool. Yeah, so standard output just means it spits it up on the terminal for us. So yes, spaces in names. Spaces in names generally are a big no-no. I mentioned this a little bit at the start. Basically, it's because the terminal tries to interpret spaces as part of the command. So if I make a new file with spaces in it, yeah, let's go red dragon. Big deal, what do I want to do? So now I have red space dragon.txt as a file. If I try to, what are we trying to do here? So basically to loop over the files, you have to put them in double quotes, and you also have to do that when you're making the file. Because if I just try to go touch red dragon without double quotes, it's going to make two files for me. It's going to make a file called red and a file called dragon.txt. Basically because, yeah, the terminal interprets the space as me wanting two separate things, when obviously in this case, that's not what I want. I don't want a file called red. So we're going to get rid of that. I'm going to get rid of dragon. Basically, the motto of the story here is don't use spaces in your names if you can avoid it, because they make everyone's life a bit of a pain. And then we get lots of errors if we try. So if we try to do a for loop and we use file names that don't exist, we're going to get errors like the ones you see here. Cannot open this file. I guess moral of the story there is try and make sure that your files exist first. The thing to note about that is if I try and do this loop in a file, let's just say we just want to echo the file name. Aha. Okay, that was a silly example of mine. So we're going for file in for file name in not a file.txt. Let's do head. File name. Yes. So this is not going to work. Echo worked because echo is kind of clever and it just expands my file name and echoes the file name. So that's all good. But if I actually tried to do anything with a file that doesn't exist, like look at the first however many lines of it, it's not going to work because the file doesn't exist. So there's nothing for it to look at. And then what else are we doing here? So if we want to modify the files, but also save a version of the original files, naming the copies. Okay, so if you wanted to, so this is basically this just another another use for copying files. So if we wanted to have an original copy of our files and make a new copy that we wanted to change, we can use wildcards to copy all of the files in a folder. So I've got all my files here. Let's get rid of red dragon because it's annoying me. Now we have our nice file. So if we wanted to make a copy of all of these, we can use our wildcards copy.dat. And I'm going to prepend something onto these so that I know which files I'm changing and which files I'm keeping. So in this case, we are prepending original to all of the file names. Original.dat is not a directory. Interesting. What have I done here? Original.dat is not a directory. Interesting. That gonna work? No. What am I doing wrong? Can anyone see my mistake? I'm clearly having a mental blank. Ah, no, see, I didn't read the instructions properly. So the issue is we can't do this because, of course, because copy is trying to take the first files and then copy it into the target directory, which is our second argument. But of course, my second argument is what I wanted to be the file name. So that's not going to work. Should read the instructions properly. So basically, if you wanted to copy all of these files and create a new version of them with a slightly different name, we would need to use a for loop. And that just allows us, basically that just allows us to expand the wildcards. So for file name, that do copy file name, and then we're going to copy it to original file name. And now I have my original files, and I also have, I misspelled original, but that's okay. I have my original files and my new files, which is just a copy of them. So I can make changes to one and keep the others in their original states. So we've got a little diagram in the lesson, which basically just shows you how these for loops work, if you want to have a look at it graphically. And then finally, we're going to look at processing some of Nellie's files using a script that she has been given by her supervisor, goostats.shell, a shell script. Okay, so this is kind of a new stage in this exercise. So if anyone has any questions about what we've just done, now's the time to speak. Speak now, forever hold your peace, as David says.
Could I have like 1 minute to make sure I've got it all?
Absolutely, yes. Okay, so how are we feeling about heading on to the next thing?
Yeah, good.
Yeah, excellent. Okay, so now Nellie's been given a shell file by her supervisor, goostats, and this file is going to do two things. It's going to take an input file with raw data, and it's going to do something with that data and then spit it out to an output file. But we're going to look at things in stages like Nellie, because we are still learning to get used to using the shell and the command line. So the first thing we're going to do, we are currently, where are we? We're in creatures. So we're going to cd out of creatures, and we're going to cd into North Pacific Gyre, and then into the data from 2012. Okay, now we're going to do a for loop that basically just loops through and lists all of our data files that end in .txt. So we don't care about the .shell files at the moment. We just want to see the data files. For a data file in a.txt. So can anyone tell me, so this first line here, what's this gonna, what does this do? Why have I got the wildcards here? Anyone?
You're just selecting multiple of the files.
Yep, exactly. Oops, whoopsie. Done. Yep, and so it's printing out all of the files ending in .txt, but we're ignoring the shell files for now. Okay, so now we need to work out what we want our goostats program to output in terms of file names. So here, Nellie is choosing to prefix each name with stats because that seems nice. So now we're going to go back, do our for loop again. So for data file in all of our files, we're going to echo data file. And we're going to prepend stats to the data file name. So if we print that out, data file. So now we have our input data file name, and then it's going to pipe out to stats for each of those, which is nice. That's very exciting. But we haven't actually tried running the function. Now we know though that we can select the right files and we can alter the name of the output file depending on what input file we're putting in. So now we're going to alter our for loop again. And I'm just going to use the up key to get my history rather than typing it all out again. And what are we going to do? So we've got do echo data file, stats data file. We're going to change this line where we had the do done from echoing to, we're going to call our goostats file. So make this a bit bigger, so it's all on the one line. So in here, instead of do, echo, whatever, we're going to have goostats.sh, and because it's a bash file, we need to put bash. Basically, we need to put bash in front of the name of the shell file so that the terminal knows what kind of code it's trying to run. And I think that's all I need to do. So let's see how we go. And now it's going to think for a bit. Bash is doing things, but there's no output. So we're not printing anything, which is a little bit of a pain. So if this ever happens to you and you kind of lose your prompt arrow or your $sign and it's just kind of hanging here, it's usually at this point, you don't want to hang around for too long and waste time. It's easier just to kill the process. So we can kill the process with Control-C, and that brings us out of the process and back to our shell. We can see we've got our prompt back. So now, to make life easier, we're going to add back in echoing our data file so that we can see kind of how long roughly it's taking to do each of these files to run it through goostats.shell. So we're going to echo. And we're going to run that. And you can see that, okay, so now I know that it's processing this file, it's processing this file, things are moving, basically. That's just kind of a sanity check for you. And that's all that's saying there. So we can move to the beginning of a line in the shell by typing Control-A. So this Control-A and Control-C, that's just moving your cursor around basically in lines in the shell. They're just kind of useful tricks to know, useful tricks to be aware of, particularly when you're dealing with lines that are getting quite long, like our for loop was here. So, perfect. It's finished running. I don't have to cancel it. So the other useful thing to know, David's talked a little bit about history so far. So you can access history with your up and down arrow keys. You can also access it with the history command. Now I think if I do this, it's going to pipe out a lot because we've been doing lots of work today, which is all very good. But if I just want to see the last, let's say 10 commands that I've done, we're going to use a pipe. We want the tail and we want the last 5 lines. And you can, oh, that's a bit silly. Let's try that again. So you can see now, these are the last 5 things that I've called in my terminal. So something that's interesting to think about here, and this is probably an exercise later on, but I think it's useful to consider now. You can see that I called history as my last command. And when I asked for the history, that last command was already part of it. So basically, as soon as you type a command into a terminal and hit enter, it's stored in your history, regardless of whether or not it fails. So can anyone think of a good reason why that might be useful to have, where you have it writing to history first rather than after the command is completed? Abraham, yes, you got a hand up.
Yeah, well, actually, I had another question.
Oh, yep, no problem. Ask away.
Before that question. I can only recognize the structure or the loop structure for and do. But does exist the loop while in this kind of language?
Is there a while? There would be a while loop. I haven't write one in a very long time.
All right. I'm just curious about it because I can only see such structures in Python and R. Those kind of structures exist. Actually, I'm using that kind of structures actually.
Yeah, so I think let's see if I can remember how to do it. So in Bash, I think you can go while. You need to give it. David might have to help me here. You've got to give it a variable, and you've got to give it a variable increment. So you need while then we need a condition.
So it's basically going to be like while, and the condition I recommend using the test command. So I'm just going to paste something in the chat that's, I think, a reasonable example. Apologies for the formatting, but you know, because thanks. And you also need I find so there's 3 ways to use the while command. You either do the while and you give it like the test command with the brackets, but that's a bit advanced. There's the y colon. The colon is like always true, so you can do while true if you really want to, which kind of sucks. But the other main use I find for the while loop is you go while read. So I'll paste another one that I have just grabbed out of one of my scripts. Sorry, Daniel, I sent that as a direct message. That was not my intention. Thanks, Dan. There we go, in chat, that one. That one is a better one. But another interesting one is like if you want to read lines from a file and you don't know how many lines there are, you could just go like for line in file or everything else, but you can also do like while you know while you read line, something like that. It's another way to do it. I find I think while loops in Bash are like even less readable than for loops, so I don't see them used too much, like unless you want a specific like an infinite condition type deal, which is kind of bad anyways.
All right, thank you.
Oh, good.
Amazing, thank you, David. So where were we? Yes, we were talking about why it might be useful to have the last command you ran, irrespective of whether it's failed, succeeded, finished, unfinished, why it writes to history straight away. So Abraham, do you have any ideas on that?
No, sorry, what was the question on that?
So why is it a good idea to have commands written to history as soon as we enter them, as soon as you hit enter? And think about what happens if things die, if things, if we get badness. So let's say, for example, let's say this wasn't the case. Let's say you enter a command and it only gets entered into history after it's finished successfully. What happens if you have a command, you enter a command and it causes your entire system to lock up. If you're on Windows, you get a blue screen of death. If you're on a Mac, it just dies. I don't know what Macs do. And you don't know what that command was. Why would that be a problem?
Well, first of all, you have a record, so you can remember that kind of stuff. And you need to repeat that several times. You can do it without a loop. That's it.
Yep, exactly. Yeah. So we write it to history straight away. Basically, for troubleshooting, it's much easier to tell what has caused a problem if the shell is keeping a record of things as soon as possible, basically. So in terms of other useful commands for history, Control R is a good one. Control R lets you search your history. So let's say I want to look for all the times I have made a directory. So you can see I've made something interesting there. That was where we were looking at making multiple directories at the same time. If you want to what else do we need to do? Control R to additional earlier matches, and we do left and right arrow keys. Oh, yes, and if I press enter, I make the command, if I run the command again. So now I will have observations in here, which we don't want, but that's okay. So control R to search, make dir. Left and right arrow keys to set it up ready to run again. So that's something useful if you know that you had a command, particularly if you had a really long command that you know worked really well and you want to find it again, save you from searching through your history or typing it all out. Something else that's useful is, okay, let's make my last command ls, is the double exclamation mark. So that's going to recall the last command that you did. Again, useful if you're typing out really long commands. The other useful thing is, let's say we want to look at, let's move out of this directory for a second. Let's say we want to look at, what's it called? Okay, let's say we want to look at the contents of 2012. Excellent. And then we want to recall just the last word from that command, maybe because we can't remember what the file or the directory was that we were looking at. We can use exclamation mark $, and that's going to spit out the very last thing, the very last word of our last command. So that's useful for retrieving file names, directory names, things like that. Okay, so now we have another exercise. So we're looking at different loops again. I'm going to give you guys a minute or so to look through this, and then we'll have a quick chat about it.
What is less?
Ah, excellent question, less. So less is a lot like the cat command, but it's great for when your files are really big. So I'm not sure how big these files are here. Let's have a look. Yeah, they're pretty big. Okay, so it can be a bit annoying to scroll all the way up, particularly if I had other useful stuff in my terminal up here. So instead of using cat, I can use less. And that's basically going to let me scroll through. Okay, there's not that much in this file. It's going to let me scroll through the file like you would a man page. So it's basically really good for looking at big files. So you can use the arrow keys to kind of flick through different pages of the file and Q to quit out of it again. So the output of the file is also not persistent in the terminal. As you can see, once I quit out of it, I'm just back to the last line that I entered, which was less. Does
So
that make
it's
sense?
just not as long if it's a long file.
Yeah, exactly. Yeah.
Like it's like the last so many lines or the first so many lines.
First so many lines, and then you can use the arrow keys to kind of scroll through.
Okay. And could you do the demonstration of when you did Control R? Yeah.
So Control R. So let's say I want to see when I moved things. So I can look at move. So that's telling me the last thing I did was move all the .dat files to analyzed. And if I press Control R again, then it's going to, the next time I called the move command further back in my history. So if I keep pressing Control R, it keeps going further and further back for all the times I use move. And then if I decide, okay, I want to.
Wait, it's not, am I pressing the wrong buttons? So I type, first you type move or Control R?
Control R.
Okay.
And then you type in whatever you want to search. And then you can press Control R multiple times to keep going back through your history.
All right.
And then if I decide, I want to use this command move quotes.txt to here again, I can just press the right or the left arrow key. And then that sort of gets me out of search mode and I'm able to just press enter and run it. So of course, I don't have a quotes file to move here, but that's how you do it. Left and right arrow keys and enter. Sound good?
Yep.
Awesome. Okay, so has anyone had a chance to have a look at these exercises? What's the difference here between version 1 and version 2? So in this case, we don't actually want to do anything. We just want to, we don't want to write anything to a file. We just want to see hypothetically what would be written to a file.
So I've tried them out and I was just wondering how come for version 1, when you do echo cat data file, how come that doesn't show anything once you run it?
So let's think about it. What are we doing here? So if we're doing echo cat data file, let's say echo cat, So if we're doing that, but then we're piping it to, so it's going to be because if we're not piping, right, we're getting output to the terminal, we're getting cat file name. But because we have the append in, everything that would otherwise be echoed is now being sent to append rather than being sent to the terminal.
Okay.
So if I look in test, I will get what would have been the output to my terminal inside the file test.txt here, or in that case, inside the file all.pdb.
Right. Okay, yeah, and then version 2 is correct because that just prints every single data file for the amount of how many we have. It's like its own line.
Yeah, exactly. So this is another one of those cases where evil spaces are making our lives difficult. So by enclosing all of this stuff in quote marks, we're saying, well, we actually want to echo all of this output. Whereas in the version before, the terminal was reading the spaces and basically executing the commands sequentially as it read them. Sound good? I'm assuming silence is all good. So we will keep going, we will press on. And last little exercise we have here is on nested loops. So most of you have probably seen some sort of nested loop before. If you've seen one loop, you've kind of seen them all. But I think it's a good thing to go through really quickly. So here, what do we want to do? We're using nested loops to set up a directory structure to organize some experiments. So what would the results be of the following code? So here we've got a for loop looping through these files. And then inside that for loop, we've got another for loop. Does anyone want to take a stab at what this is going to do? How about, oh, yes.
First of all, is going to, well, the first loop is going to be running through the species file. And at the moment that it's selecting a species, then it's going to run over the temperatures. And then it's going to pass to the next species, then again to the next temperature.
Yep, excellent. So for every combination of species and temperature, we're going to make a directory combining those two variables. So we're going to have what, 3, 1, 2, 3, 4, 3 by 4. So we're going to have 12 different directories output by this for loop. How does that sound? Does that sound good to everyone? Have people had a chance to try out the code and see what it looks like? Can I get a thumbs up if we're good? Thumbs up. Excellent. Love seeing thumbs up. Thumbs up. Perfect. Lovely. Lots of thumbs up. Okay, so that is the end of the loops lesson. Main takeaways should be, for loop structure is for, do, and done. Be mindful of your $signs and your angle brackets, both when you use them and when the terminal spits them out at you, because they mean slightly different things. And yeah, we can use history as a way to be a bit lazy and look back through our past commands and use them again. So now that we've done that, I will hand back to David for our next session, our next lesson on file permissions, I believe. Yes.
Okay, so I'm just going to get straight into it because there isn't that much to cover on the file permissions front, on the file permission side of things. So I'm just going to share. So if I go to the, let's see, if I go back to our shell lesson data and I run a ls-la, we get a number of interesting things of output. And the one that we need to focus on for this section is the first column, which is this drwx thing. And these represent the permissions for the files. So Unix is historically, well, Unix was the first multi-user computing environment. So where multiple users were designed to use the same shared computing resource. And when you introduce multiple people trying to use the same resource, and that is, and it's expensive and there's costs involved, you need to lock down the permission so people can only access what they need. And file permissions are just one part of that. So from this, we know that, well, from this first column, you can see there's really only a few things you need to worry about. There's RW and X, so that's read, write, execute, and then there's, for the directories, there's this D letter. And if there's a dash anywhere, that just means that permission doesn't exist. So you'll notice that it comes in, there's 3 groups of 3. There's the first group of 3, a second group of 3, and a third group of 3, and then that directory or not indicator. And all that means is that the permission is revoked. And so those 3 sections of RWX represent the 3 categories of users we are catering for. The first is the user, the second is the group, and the third is for others. So, for example, on this file here, it's for the creatures file, it's a directory. The user has read, write, execute permissions. The group has read, write, execute permissions, but other users only have read and execute permissions, meaning they can't write or modify this directory. And this can be very, very useful. We modify file permissions using the change mod command. And that the change mod, essentially you say for a given file, so let's say I want to make the creatures, I want to say change mod creatures, and so change mod, and I want to give the other, I want to give it write permissions. So I say other, and I give it write permissions on creatures. And so now if I run ls-la, you'll notice that creatures has write permissions on that particular directory, and it's also got some extra highlighting. And let's say that I want to revoke the read and write permission, read, write, execute permissions for the group. So I'd go change mod, I'd go group, and I want to remove read, write, and execute on, let's say, molecules. And so now if I go ls-la on molecules, you'll notice that there's now no read, write permissions or execute permissions for the group on molecules. And so I can still go in because I'm the user, but if I was logged in and as another user who was a part of the same group, that would not work. Now, by this point, you're probably wondering, what the hell is a group? And a group is just a collection of users. So if I run the groups command, you'll see that I'm in the libvirt, the craft bucket, lightdm, wheel, and my own user group. And these just represent the different, it's a way of segregating permissions once again. So you might find if you're in wheel, that's like the system administrator group. Libvirt is for virtual machine management. Craft bucket just means I can administer my own Minecraft server on my own machine because, well, why not? And lightdm is just a login manager. And this is going to be different on every single Linux machine. You might see audio, video permission groups, all kinds of things. And you could also have different groups for different file systems. So, and in the Pawsey app, in the context of Pawsey, everyone should be in their own project group. So you'll definitely want to be aware of that. So I think I'm going to skip over most of the exercises here because they're not particularly relevant. I will, however, ask for a volunteer to come forward for the changing permissions question. If anyone wants to have a go at the changing permissions question. Otherwise, I'm going to have to find a suitable volunteer forcefully. Is it Helen? I haven't heard from you today. Are you there? No, but I can't.
Yep, I'm here.
So the changing permissions question.
You mean right at the bottom with the bash?
Yes.
Okay. So it's giving read, write, and write. So read, write for one user and read for other users.
Mm-hmm.
Is that the one you're talking about where it says?
So there's two questions there. There's the what permissions will the following command give, and the what is the command for setting positions. I'd like you to answer both of them.
Oh, hang on. I think I went down too far.
It's the second last question. Well, it's the second last large orange box, and then there's 2 questions in it.
All right. So, so it looks like it's going to give read, write, and execute the user groups and others. Is that right?
Yep, it's giving full permissions to everyone, which is correct.
Yeah.
And the second question?
So what's the command for setting permissions?
This one's a bit of a tricky one.
So the read, write. For the user plus the read, write. It looks like it's only going to give read to most other people. Group, is that right?
Yep, we need to give just read to group.
And the others, anyone else has execute.
Yep, so what would that look like as a command, as the change mod command?
So user U plus RW. And then G equals R and O equals X.
Correct. Awesome. Now the good news is that's literally as complicated as it can get with change mod, is that kind of command. And I'd hazard money that most Linux people don't actually know that you can do those kinds of things.
So if you've got a partition computer, you have to set yourself up as admin in both. I mean, I'm just talking about like a personal computer. This would be, if you've got that and then you're logging into Pawsey, you need to the Pawsey application is sort of seen for a different set of permissions, isn't it?
Yes, that's definitely separate. This is just Linux file system permissions, not project or allocation permissions.
Right.
Because Slurm will have Slurm and the Acacia storage have their own sets of rules, which we'll be covering at another time, most likely. So, a bit of a quick one there. I will mention.
So why does it say, why do you do equals instead of plus just in the first one? Plus instead of equals just in the first one.
The answer is that generally, the answer is it doesn't matter. You can do equals. It really doesn't matter. It actually doesn't matter in this particular case. I think maybe it's because the previous permissions of what the example directory were, it made more sense to, I think it's related to the previous permissions for that one were blank for the user, so you have to add, it's made more sense to add them, whereas for the other ones you were taking it away, and it's easier to take things away with equals, honestly, there's 5 different ways you could answer that question. It doesn't, depending on
because it says add is plus, but assign is equals. So it looks like the same thing.
It doesn't particularly matter in this case, but you're all right. And for those of you who are interested, this whole RWX stuff is just a binary, can be represented as binary, as applying the permission or not, and you can represent that binary number as an integer from 0 through 7. So if you ever see a command that's like change mod 777, that's just adding full permissions for everything, because it's 7 is 111 or read write execute, and 777 is read write execute for the 3 groups, and that's all you really need to know about permissions. So I will, unless anyone else has any questions, I'll hand off back to Emily to cover shell scripts.
Yep. Okay, silence is probably a good sign. So we will head back onto shell scripts. Okay, so yeah, we are running a little short on time, so I'll try and distill the most important bits from shell scripts for you guys. So basically, in the last lesson I did, we used a shell script. We used goostats.shell. But that's if one is given to you. What if you want to make one of your own, say using the for loops that we've been talking about, or piping that David covered before? So this lesson covers a little bit of that. So first of all, we're going to CD into molecules. Where are we at the moment? We're in the jar. We don't want to be there. Whoops. So we're going to go to molecules, and we want to make a new shell script. We want to make it something called middle.shell. So nano middle.shell. So we're just going to use this line that we're given in the tutorial. Does anyone want to tell me what this line is going to do? Well, I just copy and paste it. So we're taking head and piping it to tail. Anyone want to pipe up what that's going to do? Save it. How about, who have we not heard from in a while?
Daniel answered in the chat.
Oh, we've got an answer in the chat, do we? Excellent. I love answers in the chat. Take the last 5 of the first 15. Excellent. Yes. Thank you, Daniel. So this is going to take lines 10 to 15 from octane.pdb. But so if we wanted to try and run it just as is, middle.sh, we will find that permission is denied. So this is because of what David was talking about before, permissions. So if we look at middle sh here, it's not got any X's, which means no one has permission to execute it yet. So we're going to change that. Now we're going to give everyone permission to execute, and we're just going to do that with chmod. We're going to do all here, but you could select other user group individually as well, but I'm just going to make it a bit faster, use A. We're going to add +X to middle.shell. Okay, now that that's done, we can either go bash middle.shell, and that's going to run our script, or we can also just say, because it's a bash script, we can basically just give the shell the file's location and name. So that's what // is doing. It's saying we're in this current directory, and we're going to run middle.sh, and that gives us exactly the same output. Okay, the other important thing to note here is really what we should do if we want to now change middle.sh, and we want to make it so that instead of just reading the file octane.pdb, we can read any file. We can get rid of this, and we can put in a variable like we did in our for loops. But we should be careful to enclose it in double quote marks, again, because we want to avoid the curse of spaces mucking up our commands. So I'm going to do 1. So that 1 is going to represent the first argument passed to the bash script. And then I'm going to go Control-O to save. Yes, Control-X to exit. And now we want to run middle.sh, and we're going to run it on octane.pdb again. And we should see we get exactly the same output. But I can also now run it on, say, methane.pdb, and we get some different output. Is there a question? Comment? Thought? If not, that's okay. Nope. Okay, we will move swiftly onwards then. So double quotes around arguments, we talked about that. We need to do that to avoid spacebar badness. What else is important here? So yes, the other important thing to mention is, what if we want to pass some unknown number of commands to our shell script? We could continue to edit our shell scripts adding in some infinite number of variables, but that's not very useful, because that means we always need to input a certain number of variables. I mean, I could change this one to 2. So then it's going to take in the second variable. So it's going to take in variables 1 and 2 from our command line, and it's going to use the first one here and the second one here. That's all good. But what if I wanted to do this for some unknown number of files, say. Let's say I wanted to do it for all the files in my directory. So if we change this back to 5, what we can do, so if we want to do it for all the files in the directory, we should be thinking about a for loop. So we're going to say for file name in, and we're going to use the @ symbol. And what this does, this tells us that, or this tells the shell to basically look at all of the input variables that are given to this script and use them all here. So we're saying for file name in all the files that I'm giving you, however many there are, I want you to do, and we're going to do our same command again. I'm going to do head, and this is going to be file name. And then we're done. And we're going to save that and write it. So now I should be able to go in middle, and I can just give it 1. Whoops. And I need to tell it where the file is sitting. So I can just give it 1. I can give it 2. And it's going to give me the output for both. I can give it 3. What's another name of a file? Pentane. And it's going to give me the output of all 3 in a loop. So the $@ symbol is another useful one for you to keep in mind if you don't know how many inputs your shell script is going to take. So it's particularly useful for shell scripts that use for loops because it's easy to iterate through a set but unknown number of variables. As Helen brought up earlier, even though we don't know exactly how many there are, the script is going to work it out for us. It's going to expand that @ variable into a set number of file names or whatever other thing you're looping through.
Can you just show the text that you put in the bash script?
Sure. So I've got for file name in, and then this is my special kind of wildcard character in however many variables I give you. Do our function again, do take 15 headlines from my file name and pipe that to tail to give me the last 5 of those lines, and done.
Yep, cool.
Excellent. Get out of that. So we don't really need to do list unique species. We've talked about why history matters. So now I think we can come down to, we've talked about variables in scripts. I think it's most important for us to come down to the last 1, 2, let's say the last 2 exercises in this section. So from scripting, reading comprehension, and debugging scripts. The other exercises in here are definitely good to do in your own time. They're kind of piecing together different functions and different commands that we've used throughout this session, but these 2 are kind of the most essential skills. So I'm going to give you a little minute to read the exercise on script reading comprehension. What you want to do is look at the bash scripts and we're going to think about how they're different. And feel free to run them if you're not sure, see what kind of output they give you. Okay, so we're giving each of these bash scripts the same input, as you can see from the second line up here. We're giving each script 1, 2, and 3, we're giving it all files ending in .pdb. So does anyone want to tell me what the first script is doing here? Who have we not heard from? Jordan, are you able to turn on your mic at the moment?
Yep.
Yeah, cool. So
So
what's this?
Or
This is the
echo,
first script. Yep, echo.
it'll just print out anything with a .NET, but since you only asked for the anything ending in .pdb, it'll just output all the files ending in .pdb.
Well, so this is an interesting one. So this first script here is not actually doing anything with the variable that we gave it, the .pdb files.
Oh,
This is just saying echo anything.
Oh, yeah, then it'll just print out everything with a dot in it.
Yep, exactly. Yes. And then, so how about the second script? What's that going to do for us?
So the $1, $2, $3 are the first argument, second argument, and third argument.
Mhm.
And so it would just, for each of those, it would just output the file name. So it will output $1, $2, so output the first three. It will just output the contents of the first three files.
Output the contents. Yes, very nice. Excellent. And then how about the third one? What's that going to do for us when we're using that @ sign again?
What does @ sign do again? Is that
So this one, remember, this takes however much input we give the shell script, however many variables we give it, it's going to take all of them and use all of them, whether it's one shell, whether we give it one file name or 3 file names or whatever.
Okay. So yeah, so for every time you're running a script, you're giving it all of the files endian.pdb. So whatever, it depends on what's in molecules, endian.pdb. And then it would just echo would just print it out. So it'll print out all the file names.
Yeah, awesome. Sounds good. Is everyone happy with that? Can I get thumbs up if we're happy? 1 thumb up, 2 thumbs up, 3 thumbs up, 4 thumbs up. Excellent. I think that's the majority thumbs up. So I'm happy with that. Okay, and then I want to take a quick look at this last exercise here, debugging scripts. So this is something that you're bound to come across if you do any kind of coding. We make mistakes, other people make mistakes, we find mistakes in code, we write mistakes in code, and this is just a little bit about how to pick those up in a shell script. So we have this shell script here called doerrors.shell, which is looping through all of our files and it's doing some stuff. But when we run it, the output is blank. So to figure out why, we can use the X flag, and this is going to give us some useful output. So I'm going to give you guys a quick minute to try that, and then we're going to discuss what you get. So first, you're going to have to make the shell script, which is good. Oh, actually, are you going to have to make the shell script? No, maybe we already have this one. Let me check. Where are we going to? Yes, you're going to have to make it. So we have goostats.shell, but we do not have doerrors. Okay, so has anyone had a chance to run that one? What do we get? Do you get no output? So I'm getting blank lines printed, which is not particularly helpful. And it seems to be going on quite a while, which I would find quite frustrating if this was something I needed output from. So I'm going to Control-C to cancel this process because it's annoying me. So now we're going to use the X flag. Okay, and so this is telling me where I'm getting problems. So is everyone getting this kind of thing? Yeah. So first of all, so this is telling us we're doing 4 data file in @ that's fine. we're echoing, but then there's some issue here with the echo. So can anyone have a look at this code and tell me what the issue is, why we're not getting useful output out of this? Anyone? You're going to need to look at the code that we have here for this little do errors shell script. Can anyone see a problem? So the X flag is telling us that the error is in this echo line. Oh, I have something in
Missing
chat.
an A. It's
Yes.
missing an A. Yeah.
Yes, amazing. Classic programming error, we have a typo. So because we were able to pick that up with the X flag, the X flag told us what line the error was in, which narrowed it down. So now we could go back into our do errors and we could fix that up. We could add an A and things would work nicely now. So now if I run it, it's all working fine. I'm getting all of my lines in the script printed out, which means that everything is working okay. So when I use the X flag, if all the lines in my shell script are being printed, that means they're all running. So life is good. And we don't need to run that all. So I'm going to Control-C out of that. And so they are the main points from this lesson that we want to take away. So useful things. So you can make your own shell scripts, but you're going to need to change permissions. David looked at permissions with you guys before, so you should all be permissions experts now. You're going to need to give those execute permissions for at least yourselves, maybe your whole group, if you want to say allow your supervisors to run your scripts on Unix. The other useful thing, most important thing I think from this lesson is the $sign at argument, which allows you to expand any number of variables that you input into a shell script. And yeah, using the X flag on running your scripts to print out what lines are actually being run in your code is a great way to troubleshoot and find some errors. So I think that's the distilled, condensed version of this lesson. Hopefully it's useful. They're all the key takeaways, I think. So with that, I think I'm going to pass back to David for our last lesson now.
What happens when you do a $sign on a command such as ls? What's that used for?
A $sign on a command like ls. So what do you mean? So we're doing like ls $sign?
No, I mean, so if you write for file in ls, then it won't work. But if you do for file in $ in brackets ls, then it will work.
That's a bit of a, so so when you do execute a command inside dollar, inside brackets and a $sign, that's spawning a subshell within the context of your existing shell. And so what it does is it spawns a new shell, evaluates that command, and substitutes the standard output of that command in place of where the brackets was. It's a bit of a tricky one because you can't just, it's a way of capturing the output of a series of commands. So you can put a whole series of commands inside these brackets and treat that as the output of like a sub-program almost. But that's very prone to stuffing up, and subshells are not easy to tame because they can do weird things depending on what you're doing. Because sometimes there's, in the bash standard, there's little inaccuracies between arithmetic expressions with like the double bracket dollars and like single bracket $signs, and then doing things in, yeah. So short answer, just imagine it's imagine it's evaluating the result of that command inside the brackets and the dollar, because you wouldn't be able to evaluate it in that context otherwise.
Okay.
Does that make sense?
Yep.
So with that, you guys might have noticed that there's another lesson left on finding things, but we are running quite badly behind time. So I'm going to give you all a choice. We can either cover what grep is in 5 minutes, or we can just leave it for now and I can leave it for you guys to go over in your own time, because grep may not be the most applicable tool for your projects, but it is still a very nice thing to know about. What do people think? If you want to go over it, put a thumbs up. If you don't and would rather go over it in your own time, then don't put the thumbs up. I'm going to give you 10 seconds to make up your mind. That's 2, 3. Anyone else? 4, 5, 6. Okay. 6. All right, that's majority. We'll go through it briefly. So, grep is an interesting tool. So let's see, right. The simplest way of summarizing it is you go grep some piece of text, so in this case, from a file, and it will highlight all the instances of where this occurs. That's mostly what grep does. You can do it in a whole directory, so like I can grep from the current directory, and I give it everything, and it will find everything in the current directory. It's quite nice like that. It will also, you can give it the n argument. So we can go -n, or if we go -nw, it will give you a line number, which is good. W tells you it just wants to match the word. And if you want to make things case insensitive, you give it the I flag, and so now you'll see this time it matches this, and that's most of what you need to know about grep. It can do a whole bunch of other things. So if you go, because I know there was a question in the chat earlier about regular expressions, grep-e allows you to write regular expressions. So in this case, we could go for is star, and it will find that. It'll find that regular expression, or say if I go dot star. So you'll see there it's recognizing a normal regular expression. That's pretty interesting. But other than that, grep's just very nice to things to sort through things. So if I go, words, so let's go data. What do we have in data? Cool. So we have a bunch of files in here, and let's say I want to go, let's go word count. Or if I go cat star pass unique to sort, and then I go to unique, what do I get? So we get unique sentences, and I can pass that to count -n. What's the count?
Isn't it a tag on unique? It's like unique dash.
Yeah. It's unique -c, and then we can, thank you. I forgot what the command was. So you'll see most of it's unique, and then we could pass this to grep 2, and we find all the sentences where there's 2, which is cool. Or we could say grep-e, and we could give it, say, a range from 2 to 9. I think that works.
So what does -e do?
-e tells it to go into egrep mode, which is a regular expression grep mode. And so there I've given it the regular expression, telling it to match numbers between 2 and 9. And so let's see, it's matched a bunch of, see, there was even a sentence that occurred 4 times in there.
And what were the other tag things that you said grep could take?
So grep, there's a bunch of other flags. So if we go, there's a bunch of other ones. The useful ones, so E extended regexp, so that's what it means. I, which is ignore case, word, which matches whole words, is a useful one. V is also useful, so invert match. So that instead of doing matching 2-9, I could do just grep v1. So this will give me all the lines that don't have 1 in it, and that also works very nicely. It's an interesting command. You'll also find there's a lot of replacements on the web like ripgrep, ag, gogrep, and others. Feel free to use it your own risk. I'm personally partial to ripgrep because it's faster. And then the only other command we need to worry about is sed. So sed stands for, I think, sequence substitution or sequence editor. And so if we go, do we have a notes? Okay, never mind. Where's notes? Oh yeah, there's notes. Our notes is there. Cool. So if we go cat notes.text, cool, and we can go. So essentially, all sed does is it takes a regular expression for substitution. So s. So let's say finish with start notes.text. I need to finish it off. Okay. And so you'll see instead of finish, we've now substituted with start. So sed's just like a sequence editor, and you can apply regular expressions. And if any of you are familiar with the Vim syntax for substitution, it's very much like the Vim substitution syntax. And then the only other command that we really need to worry about is the find command. So find so you notice I've been typed this FCF thing. Find is very similar to that. So if I wanted to say find in the current directory and I want it to be named notes.txt, and it will find it for me. Or if let's say I wanted to find data, and it says there's a data there and there's a data there as well. And so you can give it like name, you can give it you can give it a type and give it directory, and it will show you all the directories in this thing. And so this is very useful for finding a file on your system. So for example, if I wanted to find my i3 window, I could go find from my home directory, and I want to give it -name i3. And there you go, it's found my i3 config in my home directory. So that's a very useful command, and it's quite fast. So we're going to skip the exercise for this one because it's not particularly important. But are there any questions about those three commands that I can answer for people quickly?
I've got some questions.
Sure.
So just starting with that last command that you just wrote, can you just explain the parts of it?
So find, you have find as the command. The find recursively searches the file system for patterns and expressions. So in this case, I'm choosing the root file to be tilde, which is my home directory. I'm then specifying I want it to match the name criteria i3. And so it will look for files, directories, executables, which have i3 in their name, starting at my home directory.
And for the command sed, I didn't even follow that one at all.
Yeah, sed is an interesting one. So for sed, so if we go cat notes, so sed, basically you pass it text as input, and then you write a sequence substitution. So sed, what I'm doing here is I'm saying S for substitute, and I want to substitute the pattern right with the word wrote. So that's a substitution, and then I'm going to give it notes.txt. And so when I run this, the standard output, you'll notice that right here has been replaced with wrote because that's the substitution I wrote. Does that make sense?
Oh yeah, okay. And then it just sent it to standard out.
Yeah, and then send it to standard out. And so you could and then you can send things to count and grep and sort and word count, and you can start doing very, very fancy things. I once knew someone who served a whole HTML website using just seb, awk, and grep. It was wild. Does anyone else have any other questions about these commands? I know that we're probably about as quick as you can physically do it. I don't think you could do it too much faster than that, but we'll see.
Yeah, so what was grep again?
So grep is
Oh yeah, that
find
counts them, doesn't it?
No,
Oh no,
grep
it just
find-
it
grep-
finds the ones that have that character,
yeah.
that string.
So like I'm gonna say grep.
Grep is like find, but without doing the substructures thing.
So grep finds text within files. Find finds files themselves. So grep can't find. So if I say like grep my i3 config, it's not going to find it because it's grep is searching for in the contents of files, whereas find is searching the file system. That's the key differentiator.
And can you combine them to find text in a file system?
Yes. So if I wanted to say, find my i3 config, and I will pass that to, and so I pass that to cat. So I want to say cat that file, and then I pass the output of cat to grep, and I want to search for the binding for n. So like mod. I really hope this works. It'd be really nice if that worked. Yeah, so let me just make my life, because find searches everything, so it's, that'll be better. Alright, what happens here? So, yep. Hang on, so I forgot how to do this. Oh yeah, that's right. Find is a bit weird in that it. Okay, fine. We will do this the hard way. Sorry, I didn't think of this example beforehand. Subshell. Oh, that's why. Yep, this is fine. There we go.
Yeah, but now I don't know what you did there, but okay.
Yeah, that's is insert. So essentially what I'm doing is I'm saying this thing here will find the directory location of i3, and then /star is just saying cat all the files in that directory, which outputs just the single file that exists there, and then I pass it to grep to find the line I'm specifically after.
Why do you need the star?
So because at the moment find is returning this find command is returning a directory, and cat only takes files. So if I go /star here, so if I go try cat this thing.
So find just told you the directory that can.
Yeah.
Wait, does find look for directories containing this string?
It looks for both. It looks for both. So I can say just type, and I want it to find for a file. It won't find anything. If I tell it to find a directory, it will find it.
Okay, so you could have just gone find, made it actually find a directory.
Yes, but so the thing is, the file I'm actually after is a bad example. So if I find config, here's all the config files I have for a bunch of my dot files, and so I can pass these to cat. I think. No, I can't. Because you can't pass them to cat because cat doesn't treat it as standard input. It treats it as just testing the file. So I can have all of these, and then I can go cat, and then I can cat it all like that, which is a bit weird.
All right. That's all good. I have another question though.
Sure.
You know, sometimes we use curly brackets and put multiple arguments separated by commas.
Yes.
If we do glob expansion, then it doesn't evaluate to that, does it? It actually just makes it space separated or something.
So if I was, so for example, you're talking about like, so if I go ls star.text, it does, so you want to know what the result of star.text is.
Yeah.
Does this work? I don't know. So star.text, I need to look up how the specifics of what glob expansion is actually doing, but short and sweet answer is yes, it does evaluate space separated results, and then bash interprets those space separated results.
So why were we using curly brackets to make a list before?
So the reason why I believe that was with the make dir section, and the reason we do that is because of the paths that came before it. So if I go make dir, let's say a/b/c, so the reason why we did this is because we were making new things, not looking at existing things, and this will be expanded to a/b, a/c, like that.
Awesome. Okay.
Does that make sense?
Yep.
Cool. Is that all of your, anything else I can answer for you, Aiden?
Well, I mean, you posted in the chat this while code, and it's got double brackets around I++. Why is that?
That's subshell variable incrementing. Short answer, don't worry about it.
Okay.
Don't
I
worry
got
about
nothing else then.
Don't worry about it. It's just so bash doesn't, depending on the version of bash, it doesn't support variable increments or arithmetic expressions by default. And so that's just a way of hacking it in. But yeah, I've gone off into advanced bash land now, so I'm probably gonna reel it back. Are there any simple bash questions that people have that I might be able to help with?
Well, that's all my questions.
So I'm going to take the deafening silence as a you're all brain dead and don't want to talk to me, so that's fine. Thanks for coming, and if you have any questions that come at a later point, once your brains have recovered from this massive information dump, send us a message on Slack. We'll be happy to help. You have anything to say, Emily?
Yeah, no, I guess, yeah. I mean, good job, guys. This has been a long session. It's been a big push through, lots of content. So good job for sticking with it. But I think if no one has any more pressing questions, I think it's time for us all to sign off. Go and stretch your legs, go outside, get some fresh air, look at nature. And then get yourselves ready for another big day tomorrow.
Thank you.
Thank you, guys.